In this video, we're going to look at an integration using partial fractions where we have two irreducible quadratic factors in the denominator. So we're being asked to evaluate the integral of 6x to the fourth minus 2x cubed plus 17x squared minus 11x plus 8 over x to the fifth plus 5x cubed plus 4x. Again, we notice that we have a proper rational function. So we don't need to worry about doing polynomial long division to start. The denominator, we can pull an x out. We would be left with x to the fourth plus 5x squared plus 4. That factors as x squared plus 1 times x squared plus 4. So here's our denominator factored. We have three factors, two of which have irreducible quadratic factors in them. The first one's a linear factor, so it's just constant over x. For each of the irreducible quadratic factors, we'll have a general linear term in the numerator. So we'll have a bx plus c over x squared plus 1 and a dx plus e over x squared plus 4. Clear the fractions to get this polynomial equation. Notice that when you clear the fraction, the x will cancel on the a term. The x squared plus 1 will cancel on the bx plus c term. And the x squared plus 4 will cancel on the dx plus e term. We can put 0 in for x. That gives us the equation 8 equals 4a, so a is 2. But other than that, that's the only one where we can really plug in a good number, if you will, to figure out what the constant has to be. The constant a has to be. So we need to set up other equations. Well, setting x equal to 0 is our constant term, so we need to equate the other terms in the polynomial to get what the other coefficients have to be. So if we look at what the x terms are, well, notice that the coefficient on the x term on the left-hand side is negative 11. There is no x term in the first product here. The only way to get an x in the second product here is to take the c times the x times the 4, so that's where the 4c comes from. Likewise, the only way to get an x in the third product is do the e times the x times the 1. That's where the plus e comes from. Let me skip down to the x cubed terms because notice that the equations look similar. X cubed, the coefficient on the left-hand side is negative 2. On the right-hand side, I cannot get an x cubed from that first product. Notice on the second product, I would do a bx times an x. That's a bx squared. I can only multiply it by the x squared or the 4. That doesn't give me an x cubed term either. So the only way to get an x cubed term from the second product is take the c times the x squared. So that's where that c comes from. Likewise, in the third product here, I have to do e times x squared to get an x cubed term. So that's where that e comes from. If we jump down here, I have a system of two equations and two unknowns. I can subtract the equations. Get negative 9 equals 3c. That gives me c is negative 3, which in turn will give me e as 1. All right, to figure out what b and d are, let's look at the other terms. How do we get an x squared? Well, the coefficient on the left-hand side is 17. On the right-hand side, I can get an a times x squared times 4, or a times 1 times x squared. So to get an x squared out of this product, you would get 5a. Here, the only way to get it, there's a couple of ways that you can get an there's only one way to get x squared because of this extra x factor in here. I would have to do the bx times the x times the 4. It's the only way I can get an x squared out of this second product. Likewise, the only way to get an x squared out of this product is due to the dx times the x times the 1. So that's why we have 5a plus 4b plus d for the x squared terms. For x to the fourth, we have a 6 on the x to the fourth on the left-hand side. To get x to the fourth in each of these products, I need to do a times x squared, that's one way. Bx times x squared, that's another way. And then dx times x squared, that's the third way. So we get a plus b plus d on the right-hand side. Since a was found out to be 2, we can put 2 in for a, move things to the left-hand side. We get this system of equations. Again, we can subtract equations now to get the equation 3 equals 3b, which makes b equal to 1, so d is 3. Now we're ready to put in our partial fraction decomposition. Our integrand is 2 over x plus x minus 3 over x squared plus 1 plus 3x plus 1 over x squared plus 4. Each of these, the first try would be to do with the u substitution. In both of them, the du would be 2x without a constant term. So we'll split each of these fractions at the minus and plus sign respectively, and then do our antiderivatives. So we've got 5 terms to antidifferentiate here. The first antiderivative will be 2 natural log of absolute value of x. The second will be this should be a plus here, not a minus. My apologies, that's a typo. That should be a plus sign. Be a 1/2 natural log of x squared plus 1. Again, the 1/2 comes from the fact that when we do the u equals x squared, du is 2x dx. So we'll need to adjust with that 1/2. Here, we recognize that we just have 3 times 1 over x squared plus 1. Its antiderivative is inverse tangent of x. So we get a minus 3 inverse tangent of x for that one. Much like the x over x squared plus 1, the 3x over x squared plus 4 is another u substitution. We'll need to adjust with a 1/2 for the 2x dx for our du. So we'll get 3/2 natural log of x squared plus 4. And then finally, this last one is an inverse tangent. Our a squared, if you will be 4. So we would have 1 over a, 1/2, inverse tangent of x over 2 plus c.